Okay, so let's take a look at an example. This is practice quiz 8, number 1C. It says use the Laplace transform to solve initial value problem. So we're given y double prime plus 9y equals cosine 3t with y of 0 equal 1 and y prime of 0 equal minus 2. Okay, so the first step is to take the Laplace on both sides here. So let's do that. Okay, so I took Laplace on both sides. And Laplace is a linear operator, so it's going to distribute in here. So doing that, we get then. Okay, so distributing the Laplacian in there, we have then Laplace of y double prime plus 9 Laplace of y equals Laplace of cosine of 3t. Now, in Theorem 17, special cases of it for the first and second derivative, it says the Laplace of the second derivative is s squared Laplace of y minus s of y0 minus y prime of 0. We're going to apply that here. This guy does not have a y prime, so let's do the y double prime substitution. And from Theorem 15, we know the Laplace of cosine of kt is s over s squared plus k squared. Here it looks like k is going to be 3. So making those substitutions, we get then. Okay, so my Laplace of y double prime I replace with s squared Laplace of y minus s y0 minus y prime of 0. 9 Laplace y is right here. Then Laplace of cosine of 3t, I'm using Theorem 15, with k being 3. Is going to be s over s squared plus k squared. And here, in our case here, k is 3, so it'll be 3 squared. Next, we're going to note that y0 is 1, so this guy is going to be 1, and y prime of 0 is minus 2. So let's note that. Okay, so that's 1 and that's minus 2. Let's take both these terms now over here. So we want to isolate the Laplace of y. So bringing this guy over here, we get... Okay, so I took this guy over here, become plus s. Take the negative y prime of 0 over here, become minus 2. And we still have the s over s squared plus 9. Let's now factor out the Laplace of y here and here. So factoring it out, we get then. So factoring out the Laplace of y, then we'll have Laplace of y in front. We'll have an s squared plus 9 here equals s minus 2 plus s over s squared plus 9. Now we can solve for the Laplace of y by dividing both sides by s squared plus 9. So solving for the Laplace of y, we get... Okay, so solving for the Laplace of y, we're dividing everything, or you can think of it as multiplying by 1 over s squared plus 9. So it'd be s over s squared plus 9 minus 2 over s squared plus 9. Then s over s squared plus 9 squared, because it'd be two factors of the s squared plus 9. Okay, so we have this. So next step will be to take the Laplace inverse to find our answer. But I'm out of space here, so let me erase a few things and we'll keep going. Okay, so we have it here. So we want to solve for y now. So we're going to take Laplace inverse on both sides. So the Laplace inverse of Laplace of y would just be y. So you just got y on this side, and you have Laplace inverse of this guy, and this guy. So doing that, we get then. Okay, well, I'll show all the steps here. So it'll be so taking Laplace inverse on both sides. So the Laplace inverse of Laplace of y would just be y here. And Laplace inverse is a linear function also, so this will go in like this to each of these. So simplifying this, we get then. Okay, so we have then our y is Laplace inverse of s over s squared plus 9 minus 2 over Laplace inverse of 1 over s squared plus 9 plus Laplace inverse of s over s squared plus 9 squared. So we're going to be using Theorem 19. At the end of Theorem 19, I showed these two things. So we showed that the Laplace of t cosine of kt is s squared minus k squared over s squared plus k squared squared. And we showed the Laplace of t sine kt is 2ks over s squared plus k squared squared. And we'll be using theorem 15 also. Laplace of sine is sine of kt is k over s squared plus k squared, and Laplace of cosine kt is s over s squared plus k squared. Okay, so we need to change these into Laplace inverse formulas. So I can take Laplace inverse on both sides here, here, and here, and so forth. So doing that, we get then the following Laplace inverse formulas. Okay, so looking at this guy here, taking Laplace inverse on both sides, would have then t sine kt equals Laplace inverse of 2ks over s squared plus k squared from this one. The 2k I can pull outside, which I've done here, and then I can divide both sides by 2k to solve for the Laplace inverse of this guy. So I have then Laplace inverse of s over s squared plus k squared squared equals t sine kt over 2k. We're going to be using that on this guy here because that looks like this one. And we can get Laplace inverse formulas from this one also. Let me write them down here. Okay, so looking at this one also, we can take Laplace inverse on both sides. We'll have sine kt equals Laplace inverse of k over s squared plus k squared. I can pull that k out here and divide both sides by k. So we'll have then Laplace inverse of 1 over s squared plus k squared equals sine kt over k. And then we can take Laplace inverse on both sides here. Doing that, we get then. So we have Laplace inverse then from this one. Laplace inverse of s over s squared plus k squared is cosine kt. Okay, now we're going to use these in our problem up here now. Let me erase on this side and replace it with our Laplace inverses, and then we'll finish the problem over here. Okay. Okay, so we have our Laplace inverse formulas here now. Now we can figure out our answer over here. So we need to identify what the k is in this case. So the 9 is the k squared. So if 9 is k squared, it means that k is 3. Let's note that here. Okay, so our k is 3 then, because our 9 is our k squared. Then start using these. So in the first one, we have an s over s squared plus k squared. So I'll be using this guy here. Looks like it's going to be cosine. So let's do that one first. Okay, so this guy then, with the k being 3, it's going to be cosine of 3t. It's going to be minus 2 times Laplace inverse of 1 over s squared plus 9 or 3 squared. So I'll be using this guy here. Looks like going to be sine of 3t over our k, which is 3. Okay, so we're writing our answer here. We get. So we get this. And in our last guy, it looks like the top one up here, because we have an s squared plus k squared, the whole thing squared. So it fits this mold again where k is 3. It's going to be then t sine of 3t over 2 times 3, so 6, because our k is 3 here. So the answer here then will be, so it'll be t sine 3t over 2 times 3, which is 6. So simplifying this a bit further, we get then, so simplifying a bit further, we have then y equals cosine 3t minus, I'm going to bring out the 2/3 in front, 2/3 sine 3t plus t over 6 sine 3t is a solution to the initial value problem. So original question, y double prime plus 9y equals cosine 3t with y 0, 1 and y prime is 0, minus 2. So you want to verify that that's correct. I'll let you verify, but it is. Okay, so we're done with the question. So let's leave it there.